Yeah, let's start it. Okay, so we know this one, right? Uh, See, if it, yeah, milk and water. Okay, so you want to know the ratio. It is 1 is to, or we can take 1 is to 4 or something like that, right? So here there is an absolute zero present. What do you mean by absolute zero? Absolute zero will be there. Okay, absolute zero is present. Absolute zero means in the ratios we have absolute zeros. Okay, uh, like 250 ml of milk also there. Point 1 milk also there. Milk means how many liters? You know, right? I mean, I don't know whether you're getting it or not. So here the value will start from zero. Okay, the milk and water, it starts from zero only, right? But if there is interval, the intervals they never start from zero. So there is no absolute zero. No absolute zero is present. Zero value is present. Okay, let me explain this with an example. Uh, Here temperature is 4 degrees only, 4 degrees centigrade. So I'm feeling very cold. Okay, so some people they say that here the temperature is 8 degrees, so I'm feeling very chilled. Okay, some people they say here there is a 12 degrees centigrade, here also the atmosphere is very cold. Okay, then which one is correct? Then means the cool, I mean, the cool weather will exist at 4 degrees or 8 degrees or 12 degrees, or where it exists, we can't say, right? So there is an interval. So for example, 4 to like 15 16 degrees, usually the weather is very cool, like that. Or we can say zero also, not zero. Even some people they say here the temperature is -4, -4 to 16. It's cool. Means there is a range, right? So the cool means the cool is having a range. That's called the interval. So the interval means, I mean, there is no need to start from zero. Okay, no need of the zero. Okay, it won't start from zero. Okay, what is your, I mean, when you will be having the fever, means my temperature, usual the body temperature should be 37. Okay, but the fever means if it starts from 37.32 high or 40 degrees, we can call it as a fever. Okay, so here also there is no absolute zero, means it is not starting from zero, right? So these are called the interval values. Interval means there is no absolute zero. Okay, ratio means absolute zero will be there in the ratio. Okay, so these are the just two important points to remember here. So what are the terms here? What is the categorical, or we call qualitative? In the qualitative we have two types: nominal, ordinal. Ordinal follows an order, nominal it won't follow any order. Then coming to the quantitative, we have four types: discrete, continuous, ratio, and interval. Interval contains no absolute zero value. Ratio contains a zero value. Then discrete means it contains no any decimal value. Continuous means it contains the decimal values. Okay, and yeah. See, for example, I have this sex variable. I mean, what is the variable sex is called? We should call it as a, it is a ordinal type of qualitative data or ordinal type of categorical data. Okay, so for example, my height is, or my weight is 80 kgs. Okay, so what type of data it is? This is called the continuous type of quantitative data. Okay, it's a continuous one because it may contain the decimal values also, like sometimes it may be 80.5 also, right? So it is a continuous type of quantitative data. Okay, so this is how you have to identify the variable type. Okay, yeah. So yeah, this is the same thing what I explained. Nominal data. What is the nominal data? Classification data, male or female, red or black. So there is no any order here. Okay, then we can define them, or we can label them as 1 or 2 or 0 or 1 or be like that. So no ordering. Mainly in the nominal, there won't be any order. It makes no sense to state that R is greater than B. When male is more than female or female is more than female, there won't be any sense. Means there won't be any order and there won't be relationship between these two. Then coming to the ordinal. Ordinal is it's an ordered list. Student satisfaction scale 1, 2, 3, 4, 5. 1 means good, 5 means or 1 is poor, 5 is excellent like that. Okay. Then interval data. Just now I explained the temperature, dates also. It won't start from zero, right? So from January 1st to 31st December. So we are giving January 1st and 31st. There won't be any zero, right? It won't start from zero. So with no natural zero. Then ratio. Ratio means height, weight, age, all this comes in ratio. Okay. Then coming to the tables. So just now we thought to discuss this table, right? How many types of tables are there? So because when you are presenting your data, you may present the data in a tabular form also mainly. So we have different types of tables. Okay. So this is called the one-dimensional table, the first one. So it contains only the columns. That's it. There is no any row here. Column month, January, February, March, April, May, June, total. That's it. So here there is no any row here, right? Month wise, I mean half yearly sales. Is there any row? There is no row. But here we have row and column also. See, less than 15 hours per week. So under 30, 330 people. More than 30, 358 people. So here we are reading this 358 from the two dimensions. One is the column dimension, the other one is the row dimension. Here we have only the column dimension, right? So the first one contains the column dimension. The column dimension, always the data having column dimensions is called the one dimension table. Okay, having two dimensions is called the two dimension table, or we also call it as a frequency table. I mean, there are so many names for this. Tabular visualization. So tables are of three types: one dimension, two dimension, and three dimension. So if it is a one dimension, it contains only the columns. If it is a two dimension, it contains the rows and columns. Then if it is the three-dimensional table, it contains page dimension, row dimension, then column dimension. It's like this. Okay, so it contains the three. And mostly we use this two-dimensional tables only. We also call this a frequency tables or contingency table, okay, or cross tables. Okay. So I mean, mostly we use this one: frequency table, contingency table, or cross tables, or cross tabulations. Cross tabulations. This one, this is a two-dimensional table. Then, yeah. Then what is a frequency distribution? I think you know this one. Frequency distribution means mainly to create the histograms for the normal distribution. We use this one, frequency distribution. So we have data like this: 3, 5, 9, 6, 4. So use the tally. How many? Okay, how many got one score? I mean, score one. How many got two score? See, for example, you can see here there is a one, and here also there is a one. So how many ones are there? Let's make a tally and count the total 40. Okay. So this is called the frequency distribution. Okay. One second. So there is a grouped frequency distribution also there. So what is the grouped frequency distribution? Grouped frequency distribution means usually we'll be making the intervals. Okay, making the intervals. So this is one example I will show in the Excel. Consider the following data of miles recorded by 120 salesmen in 1 week. So there are 120 salesmen, I mean, working for a company. So one salesman, he told in 1 week he traveled 403 miles. The other salesman traveled 423 miles, like this. So this is the data given by 120 salesmen. Okay, there is a travel history, 120. So how to create the grouped frequency? For this, actually I created one Excel. So this is the data. Okay, using Excel to create a frequency distribution, miles recorded by 120 salesmen. 120 salesmen are there. Okay, then how to do this one? Okay, so I made a bin actually. Bin means, you know, right? 403 to 515. Okay, so I made one. Actually, these are sorted. 403, 407, 408, 410, 412. These are sorted. Okay, we sorted. So that's why here we have the maximum number and this is the minimum number. We sorted actually. After sorting, we made the bins. Bin, I think you know the bin. Bin means 399.5. So what is the 399.5? Okay, let me show you. Yeah, see this. See this one. 400 to 419. So 2020. I'm taking 20. 400 to 419. How many are there? Okay. Then 420 to 439, 440 to 459, 460 to 479, 480 to 499, and 500 to 519. So how many are there? Okay, are like 519, right? Then later 20. I mean, I'm taking the interval of 20, 400 to 419, right? We are including the 400 also. That's why it's a 20. Okay, I will explain later because we have a lot of bin types are there. I will explain that later. So 399.5 I'm taking. Okay, so this is 419.5. Why? It is 420, right? This range. Yeah, 400 to 419 is this range, bin range. 420 to 439 is 439.5. This is 459. So I'm just taking the, I'm grouping them. Actually, I'm giving the intervals. Okay. So after giving the intervals for this, then just I want to calculate the frequency distribution. Okay. Frequency distribution, how many 403 are there? How many 403 is only one, right? But I am not counting the individual frequency. What I am doing is grouped frequency. Okay, grouped frequency means I am grouping 400 to 419 as one group, and I am counting how many are there in between this 400 to 419. Okay, so like that I am grouping. So for this, what should we do? Actually, one second. One important thing is I am using I think Excel 2010. I think I am using 2010. One second, because all the old Excel sheets, I think they own 2013. I think I'm using Microsoft Office 2013. No, Microsoft Office 2016. Yeah, I think I'm using 2016. Okay, so we have a lot of, I mean, the added data analytics in the 2016. Okay, you try in the older versions also. I don't know whether they will work in older version or not. But I mean, after this, you try in your system also. If it works, that's fine. Otherwise, you have to install some add-ins. Okay, so I will explain the add-ins also how to install. Okay, so first you select the values. Okay, then go to the data. Click on this data. Now we have this data analysis. Data analysis. It is available in the latest Excel, I think. Click on the data analysis. Okay. Then we have a lot of data analysis here. we'll be discussing all these things because all this comes in the basic statistics only, like factor analysis, correlation, covariance, exponential analysis, regression, sampling, histograms, paid, Z test, all these comes under the basic statistics only, right? Then yeah, first you select the histogram and click on OK. Then what is your input range? Select this. This is the input range. And what is your bin range? So select the bin range here. Okay. Then where you want to output? So output the range. So I want to output here. Okay. Here I want to do the output. So this is the data I selected. Then this is the bin. Okay. Now, okay, let's click on OK. Output range is okay. Let's keep it in the new worksheet with the output. Click on OK. Yeah, that's it. Now we got the bin and frequency. Copy this. Paste it again. Okay. Yeah, this one. So 399 point is 0. Means there is no person below this 400, right? It started from 402. So 419.5 are 12 people like this. So if you make the total, then auto sum this 120 is given. Okay. So using this histogram, this is a group, we call it a frequency, group of frequencies. Okay, creating the group of frequency. Okay. Yeah. So this is how to create a group of frequency. Then this one we are talking actually. Okay. So yeah, class intervals and boundaries. So this is also an important thing. In the mathematical limit, there is a stated limit, discrete and continuous. See, for example, stated like this: 5 under 10. 5 under 10 means if it is a discrete value, then 5 to see. For example, in a classroom, uh, the number of students are 5 under 10. Means how many students will be there? 5 to 9. 5 to 9. Okay, under 10. Under 10 means we will be using 9 only. There won't be any 9.1, 9.2. Because if there is a 9.1, 9.2, that comes under continuous data. As we discussed, discrete contains no decimal values, right? So it should be strictly 5 to 9 only. Then again it started from 10 to 15. 10 to 15 means 10 to 14. Actually here when you see the B1, 5 to 9, 10 to 15. So here there is no any problem because it's clearly saying that 5 to 9. 5 to 9. Okay, and there won't be any 9.1, 9.2 in the discrete, right? And 10 to 15. 10 to 15 means 10 to 15. There is only, see, 1 second. Yeah, here I'm just giving 0 to 10. 0 to 10. Then 10 to 20. Then 20 to 30. So 10 to 20, 20 to 30, then 30 to 40, like this I am giving the interval. Okay, then I have one 10. Then where this 10, 11, okay, 9, like this. Then where this 10 will it fall 0 to 10 or 10 to 20? So there is a problem, right? But always it comes here only. 11, where the 11 falls, it comes here only. 11 also in this group only. Then 9 will comes here only, 0 to 9. Okay, but I mean, yeah, this one. Stated limits is like this. When you say discrete, this is fine. But when you have a continuous one means I have some 9.9. Then 9.9 means 9.9 will come here only. Because 0 to 10, right? Up to 10, 9.9, but not 10. 10 will go next. 9.9 up to 9.9 it will take. Okay, it is 20.1 means 20.1 comes here. 20.1 comes here. Okay. 19.99, it comes here only. 19.99. Okay. So this is how to make the intervals. So this is a continuous one. This is the discrete. This is stated limit. Stated limit, discrete, and continuous. So if you have the data, then where to keep those values, I mean, in which group you have to keep that frequency distributions. So that is about the classes and boundaries. Okay. So we know highest value, lowest value, and number of classes called the class width. What is the width of this one? So for example, 5 to 9, okay, or 1 to 10. 10 is the highest value, lowest value is 1. 10 minus 1, 9. So number of classes, how many classes you made. So this is how to calculate the class width. Okay. And it is a simple one. I think no need to spend much time on this. Then coming to the graphical representation. Graphical representation also based on the data types only. Okay. So it's not possible to create the histogram using all types of data. Histogram is used only for the continuous type of data. That's it. Okay. And box plot is, I mean, we can create a box plot using the categorical data only, not the time series. So using the time series, if you create a box plot, it won't work, right? So what type of graph is suitable for what type of data? So that is a graphical representation. Here, category are nominal. Bar chart, pie chart, crosstalk. I mean, this for the contingency or cross tables. Then ordinal means bar chart, pie chart, scatter. Then interval, interval ratio is histogram, frequency polygon, or histogram. For interval ratio means it is a continuous, right? So for this, we are using the histogram frequency. If it is ordinal type,
అది వేరే వేరే సాఫ్ట్వేర్
I think there is some disturbance, right? 1 second.
ఎక్స్చేంజ్
Yeah, I muted. Okay. Okay, how to create a bar chart, pie chart, histogram using the Excel. I think you know this one, or else I will show very fastly. It won't take much time. Bar diagram. So propose voting behavior. Conservative 400, Labor 510, Democratic 78, Green 55, and other. So this is a voting behavior. So how you want to display this one? We know this, right? Okay, let us delete this one and create the new one. How to create a, graph. You select this, then go to the insert. Then we have graphs. Let's take a more columns, or you take the two-dimensional one, okay, or you can take the clustered column like this. Okay. So we got the frequency. Then you can change the titles if you want. Customs, we can make. This is a basic proposed voting. Behavior. Customizing we can do. We can change the colors also. Here we have options. Data labels. If you want to add the label, then how you want to add the labels, inside or outside. Okay, like this. We have multiple options. Then axis titles also. So what is this? If it is a frequency, then you can add here axis title. Frequency, then you can add the frequency. All these things you can do. Then coming to the grid line. If you want a grid line, you can add. Otherwise, no need of the grid lines. You can add the trend line also, or you can add the data also here. Okay. So like this, you have multiple options, right? So graph you can create as per our requirement. So this is one bar diagram. Then horizontal also you can do. It's a vertical one. Horizontal is the same thing. Here, go to the horizontal. Automatically, it will convert into horizontal. Then we can create a pie diagram also. Pie. I mean, the same thing we should do in R and Python also. Okay. Select this, then insert. So that's it. So if you want to know this, what is the conservative? Actually, these are, given us with the colors, but you can add the values also, data labels also to add. 400 is conservative. Like you can add the percentages also. Okay, you can do a lot of things, right? Just double click on it. See, just double click on it. Here it will give the options, text options and chart options. then whatever you can select, you can fill. Okay. So it's a pie diagram. Then we can create a histogram also, like this. Bar diagram, pie chart, histogram, we are building. It's a histogram. Okay. Histogram means like uh, you can create the histogram, the basic histogram, right? Okay, let's delete this one.
Histograms looks like continuous bar chart, right?
Yes, bell shaped curve, the bell-shaped one. But histogram is only for the frequency actually. Histogram is only for the frequency. It which contains the peaks, right? Anyway, we'll be discussing about histogram in detail later because that is very important. If in the normal distribution, we'll be always discussing the histogram only. Skewness, peakedness, kurtosis, left skew, right skew, normal probability distributions. So we'll be spending a lot of time on the histogram. Just I will show here how to create a histogram. So histogram means we should have the frequency data. Without frequency, always the histograms is for the frequency data only. Means how the data is distributed. See here, uh, see 400 to 419, 12 members are there. 420 to 439, 27 members are there. Okay, like this. See, for example, everyone, see, this is the frequency is distributed in a normal way. Okay, I will explain the distributions later because that is a little bit confusing if I explain here. The distribution I will explain separately. So here I want to create one just histogram, right? So for histogram we need the frequency and bin, the range. That's it. So select this one and go to the data analysis, data analysis, and there is a histogram. Okay. But already we created this histogram, right? For histogram bin and this one. Now we need just to create the graph only. Already these two we have. Then go to the insert here, more column charts. Anyway, it will show here histogram also. And which one you want to select. So the diagram.
Column bar chart.
Yeah, we should change.
There is a column bar chart.
Column chart we need, right?
Yeah.
Insert. This one, right? Yeah. First select this.
Can you go to that recommended charts? Go to the
More
direct
column,
recommended.
right?
Yeah.
The column
Here.
charts. Yeah, I think this one, right?
Yeah.
This one. Then after that we can make the changes here, right? Go here. Then else right click, format format data series, right? Yeah. In the format data series, remove the gap. Yeah, this one. Remove the gap. Then this is a histogram. Right?
Width also we can reduce. I think it's
yeah.
like
Width also we can reduce. Overlapping you can do, and yeah, we can delete the width also. Trend line also we can add. Okay. Just I think we don't need this trend line now. Yeah, this one histogram. Then we can create a frequency polygon also. So frequency polygon also it looks like the same only. Select this one. Then insert more column charts. Then usually we'll be selecting the line, right? This one. Yeah, line with values. This is one polygon. Okay. Then we can create a scatter plot also. Yeah, this okay. So then this is scatter plot also we can create using this data. I think you know the scatter plot, right? So there actually the employee old production 47, then rise in the production, 4.2% the production raised. Okay, I mean each employee they worked, last year, let us assume last year and this year raising production, okay, by the employee number, or we can say some salary or something raised. So we can compare them using the scatter plots. Just select these two, okay. Then insert the scatter plot. Insert. Yeah, this is a scatter plot. So yeah, that's it. Okay. So here also we can raise in production. Then here also we can make the modifications based on the requirement. That's it. Then coming to the time series. So how time series? There is a separate topic on this one. Okay, how it went based on the time point sales data. So this one also we can create. Usual time series also it's a line only, right? So select these two. Then go to the insert. More column charts. Then line. Yeah, this one. This is a time series data. You can add the values also. Just go here. You can format, or else you can add the data labels. And we can make the modifications here. Then we can even create the superimposing different data also into one graph. I think you might be doing that superimposing. Hello. Hello. Hello.
Yes, Kiran.
I don't know. It got hanged. I think it's not moving.
We are able to hear you, but I think it's remaining time is about to close. It seems
Oh.
6 minutes. I think. Okay.
Yeah, it's like 6:47, but it's not moving actually. I don't know what happened. It's not working actually. It hanged actually. Okay. I need to close this. But it's not happening. No.
Can you move to other tab like and check?
My mouse also it's not moving actually. I don't know.
Okay.
I need to restart the system. Okay then. Can we meet tomorrow? I will fix that issue. Google Meet. Okay. And we'll meet tomorrow then. Tomorrow.
Yeah, sure, we can do.
Discuss. Yeah. Okay. Thank you for your support. Okay. Bye.
Thank you.
Yeah, thanks. Bye.
Bye.